manual had page 2, which said the part number that came on the paperwork says this is a 7.5 horsepower motor. But page 5 in the same manual, no, says it's a 5 horsepower motor. Well, that's just confusing. Welcome back to Made by J&D. Got some compressor basics. I wanted a good compressor. Some time back, I got a blast cabinet going, and my little air compressor is only a 1.5 horsepower, as it turns out. And it almost immediately runs out of air, because I need around 12 to 14, or 15 even, cubic feet per minute. And that little air compressor can maybe do 1 or 2. To get an 18 CFM or 15 or something bigger than that air compressor, you're going to have to spend a number of thousands of dollars. Minimum 5 horsepower, probably 7.5. You can do that single phase, 220 volt, but you're going to need some pretty good circuitry. 3 phase is fairly common, but not a lot of houses have that. It's going to be mainly industrial, have 3 phase. And so what I ended up doing was I had a piece of junk car over there, and I ended up trading that for a used and broken Ingersoll Rand 80-gallon. This was a 5 horsepower air compressor. This isn't the compressor that came on it. The one that came on it is there. This is the model number of this air compressor is an SS5. Now SS5s, if you do a review of them, SS4s and SS5s, sort of mixed reviews. A lot of people have good luck, but generally, or in the other case, the pumps tend to fail. Well, that one's made in India, I think. Made in China. And yeah, it failed. I don't know that it was a compressor's fault. There's a switch on the front of this here. And the fellow had left it plugged in, who I got it from. He had left it plugged in, just live all the time, and it, pressure drop, it would automatically kick in. Well, he came in one morning, and he found it had been running for a long time, overnight anyways. He's thinking something went wrong inside the switch. And it was making a horrible racket. It was still compressing air. In fact, if I had started that up now, it will still compress, but it makes, initially it makes good pressure, but then after a while it starts making some really loud racket. And I don't know what's going wrong with it. I could probably maybe try to fix it, but knowing the history or the reputation that they have, I thought I'd just get a really good, well, what I feel is a good quality air compressor. So I ended up getting an Eaton, what they're calling a 5 horsepower air compressor, but it's made in the USA. They're both single stage. That's a single stage. This is a single stage. And that both these pistons are the same size. A dual stage means you have a big first piston and a second smaller piston that boosts the pressure way up. And they have really high pressure. I didn't really want high pressure. I mean, it helps with efficiency. 80-gallon tank at really high pressure means you have a lot of air for a long time. I don't need that. They're a more expensive way to do it. So anyways, this single stage, 5 horsepower. 5 horsepower motor, which is still good, and it's a US General motor, made in Mexico, I think. But man, I thought this was going to be the cheap way to do it. This tank, and the motor is probably $200-300 by itself. The tank, I don't know, you can't really buy them on their own unless somebody's scrapping one like this fellow was. So maybe $400 or $500, $200-300 worth of tank and motor. The air compressor by itself was only $500, but or $550. But then shipping, wow, that took it almost to $900. So $900 delivered to my door. So it's still going to be a relatively expensive thing, as it turns out. But then I'll have what I feel is a good value air compressor and 80-gallon tank. 18 CFM is what this was rated for. But the differences started. The air compressor is a lot different. I mean, it still turns in the same rotation, counterclockwise. That means I didn't have to worry about reversing the motor. But the Ingersoll Rand, it ran at 1,000 RPM, maybe a little more. This is a maximum of 800 RPM. That's what they're rated to. So now, and it's made to use, this is a 3,600 RPM 5 horsepower motor. Well, it's made to use an 1,800 RPM motor. So this pulley would be about the right size if that were the case, but it isn't. So I've had to order a new pulley. It's about $30 roughly with tax, but it's a 3-inch. There's a calculator you can look at online, but a 3-inch double B. That's another thing. The Ingersoll Rand had a single A-section belt and running at a high RPM with a single pulley. Well, this is a double pulley, B-section belt, which is bigger. I think an A-section belt is like 1/2 inch. A B-section belt is 5/8, something about that. And do you need 2 belts? I don't know, but I've ordered a double B-section, double B V-belt, and 3-inch, and that gets us down to, if everything's right, 770 something RPM, so that should be good. So I've had to order that. The fittings that make this pump comes out of here. Let me show you this. I thought I could use this little, it's a cooling, it's a really neat little deal, but that there is not 1/2 inch, it's not 3/4, it's somewhere in between, so it's 5/8 copper. I couldn't find that. And even then, I tried to go to these fittings. This is a flare fitting. Flare fittings here. I went to a place, well, 3 places, and they said they don't know what this is. It's not a hydraulic fitting. It's a flared fitting, but it's not a I can't remember what letters they used. But they couldn't find any fittings that go to this size. I think it's technically a 3/4 inch something. But fellow, funny, at the last place I went to, he had a little box full of oddball things that he'd collected. And he said, this is a British BSP. Okay, well, this thing's made in the U.S. How they're using what he said was a British BSP 3/4, well, whatever millimeter equivalent that is, I don't know. But I can't find parts for it. Maybe if I went online and searched real hard, it might be real expensive. Well, I can't do that. I'm not going to do that. What I am going to do in this case is, I've already taken this fitting loose. Actually, I took it with me, because I always like examples. This is genuinely a 3/4 inch NPT, and that is a reducer bushing. So I'm going to screw that in there, and I think I have all the fittings that I need to reduce it to 1/2 inch flared fittings. And that'll get me down to the 1/2 inch fitting that I need to go into the tank. I have one here, and I've got a T-piece that'll go here. I've got an elbow that'll go here. Down here, I thought I would just use another one of these, a third one, and just go into the tank, but I can't do that, and I'll show you why in a minute. I have had to buy a flare tool, because I'm going to have to make a bunch of flared fittings. That was another 50 bucks. And I've got some 1/2 inch copper pipe. So I'll be remaking, this comes out, I'll be going 1/2 inch flared from here to here, and then from here I'll make a new piece that goes down to the tank. I'll have to reuse one of these, because I've got to screw back into the tank, and I'll show you what's going on there. And I thought I could just maybe screw into that, but it's actually a flare. It's made to accept a flare fitting, and it's not NPT, it's a 1/2 inch flare fitting. Not compatible. I thought about taking that piece out of there, but you can't, because if you go to this side, it actually has a pressure relief valve on it. You can see hanging off the left side there. Plus, on the back side, which you can't see too well, the camera is kind of in the way, but there's a fitting to accept this, which is a 1/8 inch flare fitting, which is a vent. What happens is, that's a check valve as well. The tanks need a check valve, otherwise you'd always have pressure going straight up to the pump, and you can't do that. The pump has trouble starting under pressure. So there's a check valve, all the pressure stays inside, and then when this line here goes to this switch, which has a little fitting right here. And when the switch turns off, this is a vent, and it vents the line that goes from here to the air compressor. And if it didn't do that, well, the pressure would, if the compressor started at all, it would have a lot of load on the motor. It'd be tough to do. And it's tough on the compressor. The other thing is, where this one used to screw right into that check valve there, that's how Ingersoll Rand did it. In the Eaton, it comes off of, actually not there, comes off of here, which is on the wrong side. So I've got to change this fitting over, change this one for the elbow that's over there, swap the two around, and then this will come out and go into the, actually I'm going to run it straight to the switch. The other thing that was reversed was this fitting. And that's what I was going to try to do, is just change this over to the other head. And then that would route, I thought I could just adapt down into there, but well, that ain't going to happen. So now I'll put the elbow here, T-piece here, another piece then that goes in a flared fitting that will go into the inlet to the tank. Right at the start, this has been anything but cheap. Probably would have been better just to get a factory-made air compressor that has a warranty. I mean, it's still going to be, I'll still save a couple of bucks, but at least with the new air compressor, I'd have a warranty. Right now, I've only got a warranty on the pump, and maybe that's the most important part. But motors also fail, and this already has some life on it, and it had some trouble. So hopefully I can make that work. Yeah, so I just got a lot of work to get all these fittings changed around. I had to buy new bolts because the flanges on the bottom of the pump here are bigger, taller. It's a bigger casting. So nuts, bolts, fittings, copper line, tooling, flare tooling, pretty much having to rework the entire top. Plus, the bottom of the tank never had a vent. You need to have a drain, that is. The tank had some water in it, and I'm not sure if it must have never been drained, because all it had in it to start with was a plug. And so I've got this little fitting. I had the valve, luckily, something I had from before, but I had a couple of more fittings, screws into the bottom of the tank, an elbow, and then I can access the valve near the feet instead of trying to reach up underneath it. Yeah, that'll be the last thing I do. So there you go. Let's get to it. The plate here, the mounting plate, already had a lot of holes cut in it, but none of them fit this. Actually, 4 of them did, but it would have placed the pulley in, would have interfered with the plate here. So we had to drill new holes, and I'll bolt it down first. Here's another oddball thing. I don't know where this tank was assembled, but the original bolts that held the original pump and all were an M10 metric bolt. And just in the interests of at least being able to use the nuts, I just went ahead with, and I went with socket head cap screws because that was all I could find in the right length. I think it'll work okay. I think they're also grade 5, so that ought to be good, or the metric equivalent of grade 5. I'm going to use a thread paste rather than a tape, just because I have it. Now these are just cast steel fittings, or I think cast iron, cast steel. Should be good enough for 120 psi. Everything else on it was the original pieces. They were cast iron, so I'm just following that example. You're making a hodgepodge of fittings like this. You just got to use lots of pieces. We've already got a bushing, I used a short nipple, a T-piece. It's just a lot of pieces, a lot of sources for potential sources for leaks. I think, I have to put brass. The other pieces that come out of this are brass, and those are the flare fittings that go onto the copper pipe. Lots of things. meters are actually 5/8 by a 1/2 inch NPT. Now, go figure. The 5/8, that's 1/2 inch copper over there, but it uses a 5/8 nut and flare fitting. I haven't made a flare fitting since, well, I was very young, and it was using something my dad had. That's how they used to do it. He never showed me what to do. I tried to make it work on some project I was working on back then. It just left a bad taste in my mouth, and I can't remember what happened, but I didn't use a flare fitting. Well, this is one of the things I had to buy for these 4 connections, about $50 worth of Husky. And instructions, yeah, let's see how we go with that. So it fits 3/16, 1/4, 5/16, 3/8, half, 5/8, and 3/4 inch mild steel, stainless steel, hard copper, and brass tubing. So the instructions read, I have that proud by 1 millimeter, or what did they say, 1/32 inch. I've got a caliper here, and it's in both metric. This is Urco, made in Mexico, but it's both metric and imperial. So I will set that to 0, and I will set it at 1 millimeter, which is the black scale in this. That's 0.1. That is 1 millimeter right there. Lock it in. Probably can't see this on the camera, but that looks to me to be 1 millimeter. Now it says, align the clamp screw with the indentation on the side of the flaring bar assembly adjacent to the tubing. That's this thing. Got little serrations on the insides of these holes. It's supposed to be gripping the pipe. And then it says, tighten down the handle clockwise to create the flare. Okay, it's disengaged. So apparently, it's got an automatic thing here where it disengages. Well, that's just interesting. It knows when to stop rotating. Interesting tool. So this goes in a certain distance, and then that disengages, and you can't turn it anymore. Your flare is done. Cool. Look at that. Beautiful. Okay, that device kind of left some marks. I'll have to sand those off so that the nut slides better. But the flare itself is pretty good. I just got to cut this to length now and make the other flare. One final comment. I've got the flare, but you got to make sure you put the nut on at this point. I never thought about it when I was clocking these, but I should probably have a bend in it. If nothing else, then it's going to be really hard to get the exact right length of tubing between these two. And if I have a bend in it, that gives me a bit of flexibility. So I'm going to bend this one down. It'll kind of pass behind here, and then this one I'll go half a more turn, and it'll be a slight bend in it, and that'll make it easier to both make it up and also make sure that it's the right length.